So I want to talk briefly about how 3D printing might be able to lower shock absorption and even get some of the energy out of it and lower wear and tear with cars and much more in the future. And I have drawn a simple diagram. Well, nowadays shock absorbers are rigid, not rigid, they're in one place in like springs, not throughout the entire body or the complex hydraulic setups and stuff, but the whole entire body is not it. This means, for example, that only this participates in. So to some extent, a box in the middle, what's made here, will feel the impact of everything moving. Now, if I have this box though on, let's say, 2 springs, well, it can now somewhat float in the middle, and if it goes up and down, the box is not going to move with the body as much and have even more cushioning than you could have with just the wheels being the ones cushioning. And these cushionings can cause different vibrations, which causes something called vibrational dampening. So when this goes up, this whole thing goes up with this boxes have some force momentum going down. And it's 2 different waves. They're vibrating different frequencies, up when one goes up, one goes down. And they sort of cancel out, meaning that the leftover shocks from going over bumpy roads will be reduced throughout the whole entire thing. Furthermore, instead of having to build this whole thing upper to get more shock absorbing, you can keep it in the same size and more compact. You can also make it so it's more shock absorbing in some parts of it and less than other parts of it, and use up empty space with this shock absorbing idea. Now, so reduced vibrations, and the vibrations cause a lot of wear and tear. They cause mechanical things not to fit together as well, because the pneumatics and gears are moving in pushing against each other too much or apart. They cause more heat to be built up. And if you have very delicate instruments like a rover, a lot of problems. So all this is good with reducing vibrations, and also just making it more compact, since you could even have the body be a shock absorber. Like you could have this whole thing be made of some flexible material with some shock absorbing properties in different places. The reason why we can't do this currently is because it's too hard to do this complex things. Also, we need some rigidity in some places, because the rigidity gives you, after all, the structure. When you 3D complex shapes, you can choose more what's rigid and what's not, and you can make it more complex ways of rigid. Like you could have a very rigid layer here, and more easily put something porous over here, and another rigid layer over here, with just some spaces here to add some degree of flexibility, but more modify it by mixing different materials, so you can really control the rigidity and the precise behavior that it's by placing bricks in certain arrangements that are very rigid in a soft material. You can make it so the curve fits almost anything, so it becomes more rigid with the force. I'm going to draw it. This will be force. This will be how rigid. These curves can be look however you want, but you might want different curves. You might want it to become very rigid and hard if it hits, if it be very rigid if it's a low impact, but very flexible and not rigid if it's high impact to reabsorb the stress, like a bag or like a like an airbag or something. So you don't want the airbag always, but you want it. But then again, you might want it to be more rigid if it's a very, 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 very high impact again, because then you have to decrease some of the force quicker. So you can have all these modifications to behaviors. You can have different shock absorbing capabilities, a different amount of forces and vibrations, and other cool responses that are just not possible with a regular material. Now, a bonus for this is that you could even make these materials have some intrinsic ability to reharvest some of the energy. We've talked about piezoelectric devices which can harvest energy of forces and vibrations. Vibrations are fairly easy to make, but they have efficiencies about 25 to, the really high ones they've reported are 92%, but those are in labs and on a very specific conditions. Most of these are very low efficiency ones, but that's still some energy back. And the nice thing about this energy back is also if you just have it sitting on a flat surface the whole time, it will get it might get some energy just from other stuff vibrating the ground. The other one, the other way that we could increase the energy efficiency is not the piezoelectric effect, but the triboelectric effect. Tribo means something to do with friction. And when you have two things rubbing against each other, they can transfer static electricity. Because one of them holds on to electrons a little more easily than the other one. Another one might hold on to a positive charge a little more easily. And they transfer that charge a little bit when they rub against each other. And then if you have something to collect that electricity and pass it through a circuit, they can go from one end to another one. The triboelectric effect hasn't had as much research, but it could potentially be, in some cases, more efficient, but it just needs a lot more research. It also has more potential for wear and tear in some cases because it requires surfaces to be actively more moving and rubbing against each other. However, sometimes they can be self-healing in that if you have something that's rubbing against each other in a matrix, the matrix itself could have the properties that you distort the matrix in one way and then it still works. Such as if you have a ball that is if you have a ball that kind of is in a matrix of like a squishy material, it might squish through it and rub against the material, making a little pocket that might heal itself because the material might reform around that little pocket in some ways, as we have looked at. More advanced ways of doing it that could be used is beyond piezoelectric is you could have a miniature heat engine in this whole thing, because all this vibration stuff do generate heat, and you could collect the heat. Now, they also generate, most of it goes into heat if it doesn't go into vibrations that go elsewhere. So you have the loss of vibrations that go into elsewhere, into ground and the air. That you cannot collect as heat. And that could be a good person or very little, depending on the design. But the heat person is next most. There are, of course, other ways that, like static electricity something, but a lot of those ways we combine and make heat. And you can have something like a Stirling engine, which is ultra efficient at collecting energy. And Stirling engine is the simplest, is a heat engine, which means that it uses difference in heat from hot to cold to make energy. They can be in upwards of 50% efficient, which is way beyond the internal combustion engine. The problem with them is that they're a lot bigger. They can't fit in small spaces. They can, but they could also collect heat from other sources and use this energy from like just the device warming up. You could also try for heat collection thermoelectric devices, which are like uses or other ones, but those ones do not collect heat as efficiently. Thermoelectric ones work by having two or more different materials, and when you put heat on it, electrons flow one way easily into one, but they carry the heat energy because heat doesn't flow as easily as electrons in material. So the energy, so if there wants to be an energy wants to spread, and then that pushes an electron. Then the electrons are then pushed into a circuit and back into the normal place when it loses enough electrons. All these different ways. But the last thing I want to add is there's actually a huge potential with this, with something else I proposed. And that was with this more variable adjusting gear setup. They've already had like 3 talks about it, so I don't want to make another one to dedicate that. But this squishy in-between layer that deforms could also absorb vibrations and shocks, making this whole thing, and also could even act as a sensor for it. And by acting as a sensor for it, we could readjust the vehicle or anything. And this is not, I must keep using vehicle, but this could be for prosthetics, robotics, and much more. So all these things could be combined together in just one thing. And also, we could use the different vibrations and different electrical generation of different parts of the material throughout the device here to actually give you feedback about the road or the conditions. Material tell you about wear and tear. If something stops generating electricity, it might be worn out too much. And other conditions that all might be very pertinent in maintaining this thing. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year, and 4,000 watch hours, which is really hard, but with your help, I think I can do it. And if you have any ideas for future videos, comments, or suggestions, please leave in the comment section below. Thank you very much.